Hi and welcome to DCO. My name is David Capetti, and in this video I'll be sharing with you this exercise. It's for those of you who are fairly new. I'll be going over creating the pattern using Curve Attractor and creating this dynamic pattern. The idea was to create a dividing wall that could also function as a structure, but has perforations. So I'll be going over all the steps here. If you're new, welcome. I'll post videos like this every week for people that are trying to make advancements in their 3D modeling. So if you're excited, thank you very much for being here, and let's jump right in. All right, so first thing we'll do is I'll go here to units. Let's take a look at the units that I'm working with. I will be making mine in feet. So this is going to be a fairly large design. What I will be doing is creating two surfaces. So let's go here to a XZ plane. And with this XZ plane, now we can bring in a surface that's going to be our base geometry. So I'll go here to surface. Plane surface. And we'll be using this plane as the input. And now changing the X and Y size. So I'll go here to the X. We'll go to 30. And Y, I'll do 15. Now, if you want to create a custom slider, you can go to 0.30.50. If you want to create a range from 0 to 50 and leave it at 30. Maybe this slider that I just created is better than this one. So now we'll go to this Y size, going to be 10. Next is creating the pattern that's going to go on this surface. So let's go to that. We'll go here to Vector, Grid, Hexagonal Grid. And we'll use the plane input. And now we can pick the extent and the size. So I'll go here to 15. And the extents. We can always change the size, so let's go to a range of numbers. Now we'll do the same thing here. And if the size is not what you're looking for, you can always adjust this. So now that we have this, this plane input, it's going to serve mostly as a reference. Now we're going to take this and copy it over in the X or in the Y direction. So we'll go to a move component. We'll move these cells in which direction? In unit Y direction. Now I'll give that a value. I'll go here to 5.5. So I have some decimal points. And I'll hide this plane for now. So now that we have these sets here moved with a gap of 2.5, we can loft them together. What happens is it won't come in organized correctly until let's see if we flatten the input on this one and flatten on this one. Or we have to graft both of them. So let's try graft tree and graft tree. So what this does is it organizes the information the same way after plugging it into the graph tree. And now that it's organized correctly, this is the idea of what we'll be doing for today's exercise, is extruding it, but the pattern on the inside is going to vary with a Curve Attractor. So what we'll do is, now that we've taken care of the extrusion, now we need to take these cells and offset them to the inside. So I'll go to Offset. We'll use this plane as our plane for an offset, and we'll use the cells. Now, by default, it's going to offset to the outside. So we do need to bring in a negative value and offset it using that negative value as the distance. Now this offset is going to be determined by a curve attractor. What does that mean? That means that if I create a line segment down here, I can use that line segment to change the design within the pattern. So I'll take this, and now we'll be doing the same thing to the other side, but before that, we'll take this and we'll use the curve attractor. Now, how do we use the curve attractor? Well, first you need a curve for it to react to. Then you need to remap the numbers so we know the big and small numbers. And we need to tie it to the grid. So if we go here to cells and we get the points, well, we can't really see them because when you select it, you only select the curves. So to extract the points, I'll go to a point component, bring in the center of each cell, and that's going to be the grid that's going to react to the curve. Now the thing is that I have not created a curve yet. So whether you want this fully parametric or you want this to be within Rhino geometry, we can create a curve and use that as our curve attractor, but I like to use, let's see, these points. I want to just select the bottom points. So let's see if I go to a list item, I'm able to select the bottom row. So this can create a line segment. Now that's not ideal. Let's see if we can do fit line, which would be a line that fits. Let's see if we can flatten the input on this one. A line that fits within that first and second row. And we can use this line segment to move up and down. So let's take that line, move it in the Z direction. And I'll go here to 2.500. So you can see that now we've basically moved this line segment up. That's what's going to react to these points because that's how it is calculated. However close this line is to those points, that's going to determine the pattern size. So with this, we'll go to this curve attractor and we'll do line or curve closest point. What we need to plug in is going to be our curve, and the points are going to be these points. Now as the output, depending on how many we have 85 values or 85 hexagons. Distance here, we have 5 different values. Now let's flatten the input here. Now we have 85 values. We need to flatten the input so it organizes them correctly, and also so we get the distance right here. Now if we were to just take these distances and plug them into the offset, it's going to be too big. So this is why we need to remap the numbers. I'll go back down to here. Take the distance, plug it in, and see that it doesn't work. So we need to take these values that are 5, 3, 1, 1, and we need to bring them down to a smaller number. So how do we do that? To remap numbers, you can either go to my website. I have under the free resource tab a way to download a script that will take care of this, or I can show you here 3 different components that we bring in at the same time: construct, domain. Then we're going to bring in Well, first of all, actually, remap numbers is the first one. Then you want to bring in bounds. Then construct domain. These three will remap the numbers, and I'll show you how to connect them. First, you take the distance and you plug them into the values. So the remap numbers component understands the original values. Then bounds, the distance will go into the numbers, which means that it will give you the biggest and smallest number. So the smallest number is 0.01, the biggest number is 5.5. We can use that as our source. And now the target is going to be what numbers you want to remap them to. If I said 1.500, so now the numbers, rather than being between 0.1 and 5, they're going to be between 0 and 1.5. We'll plug that into the target. And the way that we know that we did this correctly is just going to distance. We see 85 values. We see the numbers are really big or bigger than what we need. So now we go to map numbers and we see we have numbers smaller than 1. We can use this as our mapped numbers to plug them in here. And now we see that some of the numbers are still too large. And then let's see if we can flatten the input here. So what it was is the curves were coming in not organized correctly. So now we can pick this being the small one and this being large. Now what happens is, since these are going to be the openings, I want the openings to be in the middle. So I'll make this a smaller number and this a bit of a larger number, right? And now we can take this and extrude it out by the same amount that we moved the pattern. Or we can take this and just move it the same direction and loft it. It'll be basically the exact same thing. So we'll go to extrude these. In which direction? Well, in the Y direction by the same amount. So if we already have that, we have here by 2.5. We'll use this unit Y into the factor, or actually we already have that. So I create a relay, double click on this, delete this one and plug this into the direction. So now we have these that have smaller openings and these that have larger openings. And what we'll be doing is closing it off. So to do that, we'll be taking the offsets, and before the offset, we'll be doing a boundary surface. So what I'll do is I'll take this one, we'll go to boundary surfaces, plug in the curve here. Now we'll go to the offset and plug that in. So hold down shift to add another input. Now what's going to happen is they're going to overlap unless you flatten the input. And what we'll do is we'll take this and move it in the Y direction by the same amount that I extruded it. So we'll go to move this surface by the same amount, and we can join them all together. So 1, 2, 3, 4. And this will create, let me show you here. We'll take this, 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 and this. Now we can join them. So we'll go here to join, vrep. 1, 2, 3, and 4. Holding down shift, I'm adding more inputs. And now I can flatten the input, making sure that the output is, let's see if we have this correct. We have this side, we have the inside, we have the outside. and we have the loft. What's happening is some of the information is not being joined correctly. So let's disable the preview on all of this. So bring this back, disable the preview here. Okay. I see what's going to be the best thing to do here. So that didn't give us the best result. This is the other way to do this. Take this, and rather than worrying about everything else, we'll extrude. I'll copy this, borrow it, extrude it. I plugged it into the wrong one. It's going to take a second here to readjust. Okay. So now that that's wrong, the direction is going to be, this is going to be what we'll extrude, and this is going to be the direction. And it's hidden, so we don't see it. Now these are solids. And let's see what else we can show you here. With this, there are two ways to look at this, right? We can bake this, look at this just as separate cells, which I think looks cool. Or we can bring them all together. Let's see what that looks like. So we'll just do it here in Rhino. We'll do Boolean union. Let's see how long it takes to join those together, and then merge all coplanar faces. And this is what it would look like if it didn't have each cell separated. And so this is what I'll be doing for my exhibit. So you can see this would be a wall between, or even a structural wall that has a perforation, so you can save in concrete, and it can also still be structurally sound. So hopefully you learned with this tutorial how to take a pattern like this one, copy it over, and create a curve attractor. Now with that being said, I want to show one more thing. Let's go back to here and see that we can also scale this curve down. If we took this line, we got the midpoint, and scaled it, this geometry from this center point by 0.88. This geometry can be just within the inside here. Like basically I'm scaling down that line so that the reaction is only happening in a small area. And this can also become a type of curve attractor, because if you make this line segment small enough, you can even move it to one side and it's almost acting as if it were just one point attractor. So let's see if it'll move this one. And so if we go here to factor, just one. And then we can also change this up. The other thing that can be done is change the variation of how the depth of this. I won't be doing that in this tutorial, but just wanted to go over all of the things that we can do for a pattern like this. So hopefully you find that useful. I'll have the links for this on my website and in the links below. And let me know if you have any questions or ideas for future videos. Thank you very much for watching, and I hope to see you on the next one.